Assalamualaikum and hi, my name is Muhammad Alif Aidi bin Syed Rahman. My metric ID is DB19027. I am from section 02A. Okay, this video is the continuous for my project in part 2 for series and parallel RC and RL circuit. Okay, this objective is to measure the phase difference between voltage and current in a capacitance. Second is to understand the capacitive and reactance and verify the theoretical. Third is to determine the effect of frequency on capacitive reactance. And lastly is to determine the voltage and current in series and parallel RC. Okay, the apps that I use for this project is by using the Multisim. Okay, firstly we go to the series circuit. For the first, construct the circuit as we see in figure 2. Okay, this is the circuit that I construct by using the Multisim. Okay, next is the predict the current and voltage through the circuit and include phase angle at 1 kHz and 10 kHz. Okay, for 1 kHz, firstly we measure the current. Okay, this is the reading that I get is 32.553 microampere. Next, for the voltage, okay, the measure for C1 that I get is 511.242 millivolt, and for R1 is 488.29 millivolt. Okay, next we move to the current at 10 kHz. Okay, measure the current and get the reading is 46.884 microampere. For voltage at 10 kHz, the reading that I get is for C1 73.658 millivolt, and for R1 is 703.26 millivolt. Okay, next, by using the oscilloscope, measure the voltage across the resistor and the capacitor at 1 kHz and 10 kHz for VPP and draw and label the relationship of waveform as seen on the scope. Okay, for oscilloscope at series circuit for 1 kHz, okay, I run and get the reading, and we can change the scale here. Okay, the V peak that I take is 2 volt. Okay, next we move to the oscilloscope at series circuit for 10 kHz. Okay, the measure of oscilloscope, you can see the V peak is 2 volt. Okay, next we move to the parallel circuit. Okay, firstly we construct the circuit for parallel circuit. Okay, this is the circuit. Next, predict the current and voltage through the circuit to include phase angle at 1 kHz and 10 kHz. Okay, current in parallel circuit for 1 kHz. Okay, the reading of multimeter for current is 47.139 microampere. Okay, for R1 we measure this is for L1. Okay, for R1, the measure for ampere is 45.008 microampere. Next, we move to measure the voltage for a parallel circuit. Okay, the reading of the voltage is same because in parallel circuit the reading is 707.08 millivolt. Okay, next we move to measure the current for 10 kHz at L1. Okay, the reading is we get 47.139 microampere. Next, current 10 kHz at R1. Then we get the reading is 450.076 microampere. Okay. Then to measure the voltage for 10 kHz, this must change force. I forget to change the frequency. Then measure, we get the reading of multimeter for volt, also same because in parallel circuit 707.08 millivolt. Okay, next, by using the oscilloscope, measure the voltage across and the resistor and capacitor at 1 kHz and 10 kHz for VPP, and draw and label the relationship of the waveform as seen on the scope. Okay, in parallel circuit, oscilloscope at 1 kHz. Okay, measure, get the waveform is okay like this. The V peak that I take is 2 volt and the frequency is 1 kHz. Okay, next we move to the at 10 frequency, 10,000 frequency. Then we run the oscilloscope and get the scale. Okay, the V peak that I use is 2 volt. Okay, here we can see the scale and waveform at the oscilloscope. Okay, that's all from me. Thank you for watching.